Hey Thinksters! In this video I will show you how to compute a very good estimate for p with a simple algorithm implemented in Python. So this algorithm is called a Monte Carlo algorithm, and what's that actually? Let's start by a definition. This is from Wikipedia and it states that in computing, a Monte Carlo algorithm is a randomized algorithm whose output may be incorrect with a certain, typically small probability. So this algorithm sometimes will give you the wrong answer. But why would we want to have such algorithms? This is because sometimes the algorithm to compute the correct answer all the time may be very complex and take a lot of time to compute the correct answer, for example. And that's why we will just implement a simple algorithm which sometimes returns a wrong value, but through repetition we can minimize the error. And you can remember Monte Carlo, mostly correct. So the algorithm's result is mostly correct. And now, how can we find out the exact value of p? Or not exact, but get close to the exact value of p. The idea is that we have a square with surface 1, because each side of the square has length 1. And inside the square there's a circle. So the circle's radius is 0.5. And we know the formula x squared plus y squared is lower or equal to 1. That defines all the points inside the circle. So we use this formula to check if a given point with coordinates x and y is inside the circle. And we will generate points randomly on the square, like this. And then we can check how many points ended up inside the circle and how many points do we have in total. This can be used to compute a very close estimate of pi. Of course, it depends on the number of points you will generate randomly, but that's not a problem with a program, a computer program. So how can we implement this algorithm? I already have the code here. You see we have the points in circle, one variable, and the total number of points. We initialize both variables with 0 and we have an empty list of our estimates because we will repeat the process 10 times. And we generate 50,000 points on the square. We use the random module and the uniform function to compute values between -1 and 1 for x and y, so our two coordinates for the random points on the square. And this is our formula to check whether the point ended up on the circle or, and that's always true, on the square, because all our values are inside this range. So this is our formula to compute the fraction of the total surface which belongs to the circle. And then we append these values, the estimates, to our estimates list. And then we simply compute the average of all our estimates to get as close as possible to p. And as you can see, we can use the symbol of p. We don't have to write it. We can use a symbol. That's quite funny in Python. So now I will run the algorithm. It takes some time because we have 500,000 points on the square and we repeat it 10 times. So in total that will be 5 million points that we generate. And now we have the result 3.141. And here this is what is that's the exact value of p. Of course it doesn't end there, it's much longer. But 3.141, that's already 100% correct, this part. So this is a simple algorithm to estimate P, and it's a Monte Carlo algorithm because it doesn't give you the correct answer most of the times in this case, but we repeated it many times, so we got pretty close.